In this project, our aim is to create the full sine wave AC signal, that is full sine wave AC, using half square wave signal. To do this, we have to follow two steps. At first, we have to make half square wave to full square wave, and then we have to make full square wave to full sine wave, just like this diagram. These are the steps to execute the circuit. According to these steps, we will get at last full square wave, half square wave to full sine wave. This is a full cycle half square wave. Let's consider the first half, where the input signal is +1, and we can get here some current I. Here the current is dividing into I1 and I2, as R1 R1 greater than R2, I1 less than I2. These two batteries are same. So if we consider the current here will be I dash, then here the current will be I dash plus I1, and it will be approximately equal to I dash if I1 is less. Now for first half we will get the current I dash here, and as this is works as not get, if here is 1 and here we will get no current, that is the current will be 0. So here you will get some current and this transistor will be on. This is load resistance and we will get the voltage across this. From here the main current will approach here and this will become plus in first half, and as the current will go from here and this will act as ground in first half. So following this path, the current will go from here and through this, as the transistor is on, through this it will be grounded. So in first half we can get this is plus and this is ground. Now in second half the condition will be altered, as here you can see that current is 0 in second half. Let's draw the picture first in output. Here we have got the upper pulse, and then When this is 0, here will also be 0 and there will be no current here, so this transistor will be off. And if there is 0 and here we can get 1, so here is the current. And similarly the condition will be altered and it will be ground and it will be plus. So here you can see that we can get a negative pulse, opposite pulse, that is minus, and here we can get the full square wave from half square wave. Now in second step we have to convert the full square wave to full sine wave. So to do that we have to cut the edges of the square wave, and after cutting these sharp edges we will get a sine wave. So you can see that after cutting these edges we will get some sine wave, and to do that we have to use the circuit. So if this is our square wave input, we have to um, take a resistance and a inductor parallel in series with this source, and a capacitor parallelly with this, and across this load we will get the sine wave. That is, it works in charging and discharging the capacitor. When the capacitor is charging and discharging, the sharp edges of this wave is being cut to discharge and to provide the charge to charge and discharge the capacitor, and this square wave becomes the sine wave.